Hello everyone, welcome back to my YouTube channel. In today's video we are going to talk about distance modeling in ArcGIS Pro. That is, we are focusing on three aspects of distance modeling, that is buffer analysis, Euclidean distance, and distance accumulation. So when we talk about buffer analysis, that is creating a zone around a spatial feature as a point, line, and polygon. And then Euclidean distance also talk about calculating a straight line distance from each raster cell. And then distance accumulation, that's the model realistic directional and anisotropic movement. So let's quickly look at how all these tools works. So before we can create our Euclidean distance and the rest, we have to get our point data or our row data that we are going to use to create. So I already have my data here, and then I will show you how you can create your own data on the ArcGIS Pro interface. So I already have my boundary and then my point and my row data here, which I will be using for the meantime, but I will show you how you can create your own data and then store it so that you can use it to do any analysis anytime you want. So this is my boundary, and then if you want to create your own point data or road, you can just come to your catalog pane. On your geodatabase, you click on the drop down arrow, you will see this file geodatabase here. That is where you stored your project. Then you right click on it, then you go to new, and then you click on future class. So in your future class you can just type, I want to create a point data, but because I have already created a point data, if I type point there, it will not come because it will be overlapped. So I'll just type POI, and then I'll add the rest on the table of contents. So this is my point data, and then here I will choose my point, and then make sure your Z value is checked, and then you can click on next, and then the rest you just click on finish. Okay, so as you can see, I have my point data here. So before we can create it on this one, we have to go to edit, and then we go to create. So you can see our point feature has shown here, so we just click on it. Then you can see our cursor is now editable, so that we can just create our point at anywhere in the boundary. So you can just create as much as the point you want. So you can just create our point here. So this is how you create your point. And then if you want to create a road too, you follow the same procedure, and then you choose a road or a line. You choose a line, then you come and then you just digitalize your line here. Okay, so because I already have my point and my row, so I will just right click on this one, then remove it. So I was just showing how you can create your own. So the first on the list is the buffer analysis. So let's start with the buffer analysis. So you locate your geoprocessing tool, you go to your view, your geoprocessing tool, then you search for your buffer analysis. Okay, so you have our buffer here, that's the analysis tool. You click on it, and then input feature, you put your point feature or the row feature, and then output feature, you specify the name for this buffer, and then you choose your distance. So this one, my distance, I will choose 30 kilometers. So it is where the unit is, so you can just click on here, and then you can either choose meter, decimeter, centimeter, or millimeter. So in my case, I'm choosing kilometer. That's a 30 kilometer, and then a method is planner. So this will automatically select, so don't change this one. And then this one to dissolve type, just leave it to no dissolve, and then click on OK. Okay. So as we can see, we have our buffer here. So it simply means the location that's fall within the 30 kilometer. So this is our point, our what do you call it, our starting point, or our location, and all this place. So if we go to map, and then we choose measure, then we choose measure distance. So we can see from our point to the end of the circle, you can see it's 30 kilometer. So this is how we measure distance buffer analysis. So you can see from the point to the end of the circle, you can see it's 30 kilometer. Okay, so all these places fall within the 30 kilometer from the starting point of this point to the end of here. So all these places fall within. So if you want to assess the activity that fall within 30 kilometer to the starting point, this activity within all these areas fall within the 30 kilometer. So if you want to make any analysis, you can use buffer analysis to locate how a place is closer to your facility. So this one too, you can just right click on it and then change the colors if you want to change the colors. Okay, so the next one is we have our Euclidean distance, which we observe it here that it calculates straight line distance from each raster cell. So Euclidean distance does not take into consideration the terrain and then the obstacle that it will encounter. It just calculate on the straight line. Okay, so let's quickly look for our Euclidean distance. So we can search our Euclidean distance here, or we can just use our usual geoprocessing tool and then search for our Euclidean distance. Or better still, we can go to our toolbox and then we locate our geoprocessing tool, and then we go to our spatial analysis tool, and then we locate our Euclidean distance. So this is our Euclidean distance here. So that one too, you choose our points, and then you specify your location, and then you leave all the rest defaults, then you click on OK, or you click on run to run it. Okay, so let me clarify this. I nearly forget. So before we can calculate our Euclidean, we have to make sure that our calculation fall within our boundary. So before we do that, let's go back. So you can see we have our environment, our parameter here. So after setting your input and everything, you have to go to your environment, and then you look for your processing extent. So we have our processing extent here. Then you choose your study area. That's the CCMA I have here. Then your own will be different. So you choose your study area, and then we go to mask. Mask 2, you choose the same your study area. Then we click on run. So you can see after running, and the analysis will be based on the study area. Okay, so as you can see, our analysis are within our boundary. So this one, to view it well, we can just right click on it, and then we go to our symbology, and then we classify it and then we change our we have 5 classes here, and then we change our class here. So you can change the color. Okay, so this is our color. So as I was talking about the buffer analysis, the Euclidean distance tool, we can see we have our values here, where we have our deep green here, which ranges from 0.001 to 11,000. So this one we can convert it to kilometer, which this one will be 11 kilometers. So as we can view, you can go to your map and then you choose your rule, and then we can just place our rule on our starting point, and then we look at where so you can see from our starting point to the end of the deep green, you can see it's 11 kilometers as it's showing here, and then from our starting point to our red, you can see it's 46 kilometers as you can see on the table of contents. So this is how we measure Euclidean distance. So you can see we have our colors here. So if you look at the table of content, the legend there, you can see we have our colors, and then where it ranges from and where it ends. So this is how we calculate for our Euclidean distance. So the last one that we are going to do is our distance accumulation. So as I have already explained, you can see we have our distance accumulation here, which is realistic directional and anisotropic movement, that is energy cost for walking, emergency response time analysis, and then wildlife corridor modeling considering stroke plus burial. So energy cost for walking, so how much energy is cost for when working, we can use our distance accumulation to measure that. So let's move to our distance accumulation. So we also search for our distance accumulation, which can also be located in the spatial analysis tool. So we just click on our distance accumulation, that's the spatial analysis tool. So you click on your distance accumulation, then you choose your point data, and then you set your output. You can click on this one to change the location, then this one to leave the rest default, and then you click on run. Okay, so the same problem. So as you can see, we didn't set our environment. I wanted to show you how it will look like if we ignore the environment. So this is how the calculation is going to be if we forgot to set our environment. So anytime you're doing analysis, you have to make sure you always set your environment for it to calculate within your range or within your study area. So you can just click on the undo button here, then you go to your environment, and then as I have already said, you just choose your study area at the processing extent, and then you go to your mask, and then you choose the same study area, then you click on run. Okay, so I think okay, so let's go back and then redo it again. I think we have think we have a set of uncertainties here. So our input is here. Let's change our location to distance accumulation. Okay, so let's run it again and see. Okay, so now we have our distance accumulation here, which is similar to our Euclidean distance and our buffer analysis. So in the distance accumulation, this take into account the uncertainties and then the how a place can be assessed, the terrain, and then the obstacle that's how a place can be rated, and then how a place can be measured in relation to a future that's cut across the way. So as you can see, we have our point here. So let's quickly go to our symbology and then change the color so that we can view it well. So we just go classified, then we choose our color. Okay, so let's choose different color and see. Okay, so we have our distance accumulation here. Okay, so this one too, it ranges from 0.01 to 11,600 and this. Okay, so this one too, we can use our rule to measure from our starting point to the deep blue where it's in. We have our 11,000 here, and then as in kilometer, that's 11 point. This one by meter, that's 11,000. So as you can see, we have successfully calculated for our distance accumulation, our buffer analysis, and then our Euclidean distance. So this is how we measure distance in ArcGIS Pro using the distance accumulation, the Euclidean, and then the buffer analysis. So thank you very much for joining this video. I hope this video is helpful. Please you can leave your comment under the comment section, which motivates me to do more video like this. So thank you very much for your attention.